Assalamualaikum and hi my fellow friends. My name is ANAS Ashrawi bin Azizi. Okay, based on the journal Thermal Conductivity Resistant Material written by Ron Tai, I have done my research on the thermal conductivity of materials. Okay, why did I choose the thermal conductivities? It is because thermal conductivities is an important material property in industry and daily life. Knowing what to choose in cookware or the proper clothing worn to leave the house. This property is described in unit of watt per meter Kelvin, and at a steady state, it can be calculated via a measurement of thermal resistance. In this experiment also, a simple setup will be employed to observe the change in heat flow. So, how heat transfer? Heat can travel from one place to another in three ways: conduction, convection, and radiation. Both conduction and convection require matter to transfer heat. If there is a temperature difference between two systems, heat will always find a way to transfer from the higher to lower system. Okay, what is conduction? Conduction is the transfer of heat between substances that are in direct contact with each other. The better the conduction, the more rapidly heat will be transferred. Metal is a good conduction of heat. Conductions occur when a substance is heated. Particles will gain more energy and vibrates more. These molecules then bump into nearby particles and transfer some of their energy to them. This then continues and pass the energy from the hot and down to the colder end of the substance. Okay, next one. Thermal energy is transferred from hot place to cold place by convections. Convections occur when warmer areas of a liquid or gas rise to cooler areas in the liquid or gas. Cooler liquid or gas then takes the place of the warmer area which have risen higher. The results in a continuous circulation patterns. Water boiling in a pan is a good example of this convection current. Another good example of convection is in the atmosphere. The Earth's surface is warmer by the sun. The warm air rise and cool air move in. Lastly, radiation. Radiation is a method of heat transfer that does not rely upon any contact between the heat source and the heated object, as is the case with conduction and convection. Heat can be transmitted through empty space by thermal radiation, often called by infrared radiation. This is a type electromagnetic radiation. No mass is exchanged and no medium is required in the process of radiations. Example of radiation is the heat from the sun or heat released from the filament of a light bulb. What is the problem statement in this journal? I found out that the problem statement is thermal conductivity is an important material property in industry and daily. Thus, the research provide a better understanding of both thermal conductivity and thermal resistance for those who seeking some research. The objective of these experiments is to demonstrate the effect that verifying thermal conductivities have on the heat flow through a given material and to compare thermal conductivities. There are 7 procedures in these experiments. There are 3 types of wire that the writer using in this experiment, such as the firstly copper, secondly aluminium, and thirdly steel. Okay, firstly, 2 beakers are obtained. One is filled with water and placed on the hot plate. Next, the other beaker is placed on an object of similar size to the hot plate to make the lips of both beaker at the same height. Thirdly, All the wire are bent 90 degrees on both ends, creating 50mm arms and ensuring that 1 meter of straight wire is maintained. Fourthly, the bend at the end of the wire is immersed in the water. Fifth, the journalist, all 3 wire of choice are placed on the lips of both beaker to connect both beaker, as you can see in the slide. After that, the bottom of each candle is melt using some source of heat, and the candles are placed at 200mm intervals along the wire. Lastly, the water is heat using the hot plate for 50 minutes, and the temperature reading are taken at each 200mm intervals. For the results and analysis, what I can translate from the graph show a descending line, where the farther the distance from heat source, the lower the temperature, and still is recorded as the lowest temperature at the end of the wire. This is because metal transfer heat via accumulate energy in the free electron of the metal atoms. These electrons will collide with one another, transferring their kinetic energy. This billiard-like interaction will propagate throughout the metal until the energy is uniformly spread. Copper is usually considered as the best thermal conductor on a thermal conductivity to price ratio. The only metal surpassing copper is silver, with a thermal conductivity of 4 to 9.77 watt meter per Kelvin, with surprise the copper wire found to have the greatest or the highest temperature across all 200mm interval and the highest degree of metal melt candle. Okay. This table shows some data value for copper, aluminium, tungsten, zinc and bronze, and nickel, and their thermal conductivity value. As we can see, the highest thermal conductivity is copper. From the journal, I also learned that there are main factors that affect thermal conductivity. Firstly, temperature, followed by moisturizer content, and lastly, density. The thermal conductivity is not only affected by changes in thickness and orientations. Temperature also has an effect on the overall magnitude. Because of the material temperature increase, the internal particle velocity increase, and so does the conductivity. So here we go, the conclusions. This experiment might be improved by the inclusion of several more metal types, namely the inclusion of like nickel and zincs. It also could be performed with an enlarged amount of trials and an increase to the metal exposure to heat. Some source of error that might contribute to flaw or incorrect result is the variation in the testing location temperature, or an incorrect reading from the infrared thermometer. The data show that the copper has the highest thermal conductive ability of the material tested, and that it should be used for the construction of all cooling components. It is found that the usage of stainless steel in the thermal scenario should be avoided as much as possible, as it is not as efficient as copper or aluminium. The data in this experiment is conclusive and support the hypothesis, although further testing should be performed.